You ever seen how much amperage a 1-inch capacitor discharges? Here we go. Now we gotta do plug it in. Here's the discharge. We need to put it on amps though. Charged. Now, we're going to get the discharge. 0.06 for that capacitor. That's how many amps it was at 5 volts. And that maximum capacity is 16 volts, 2,200 micro farads. So it was 0.06 amps that it was discharging at 5 volts. So if we increase the voltage, it should discharge more amps. But the resistance is very low, so the resistance is a fraction. So it should only change a fraction of amps. So it will increase by a very small percentage if we increase the voltage, which means that it stores about anywhere from 0.08 amps, which is a milli, which is like 80 milliamps to 60 milliamps for this one type of capacitor here. This is about a 1-incher. So I call them blue boys. So that means that if you were going to make a capacitor battery out of this, which is what I want to do, for every one of these that are in parallel, you get about 0.06 amps. To make a battery, you need a lot of those. So if we calculate that up, 0.06, we just add 10, and then we get 0.6 amps. And then if we want 6 amps, we add 100. So 100 of these in parallel will equal 6 amps. So 1,000 will equal 60 amps, and that's a lot of amps. 60 amps is huge. So for like 1,000 of these, I'll have 60 amps. Okay, that's amazing. So you could definitely make a battery out of these and add resistors and relays and charge them with like these types of solar panels. And you could use like little 555 timer relay circuits to sequence every second to charge so many capacitors. And that's what you do. I'd have 60 amps at whatever voltage rating that each capacitor was to put out into a generation. That's huge. It's awesome. You just simply use these little capacitors and make a capacitor bank and control the voltage charge per capacitor bank per second. And you got tons of free energy.